This is Jason, Mary, and Brandon Gendro. You are viewing the video demonstration of our 2013 senior project. We are seniors graduating from Vermont Technical College with a bachelor's degree in Electro-Mechanical engineering, and this is our fish tank monitoring system. Our system is broken up into 4 parts: a water level, a temperature control, impact warning, and angle warning. So the first portion of the project is water level, and within a tank, keeping a nominal level is key. Water can drain inside a tank through 2 ways: evaporation and through the cleaning process. During the cleaning process, a number of water will need to be emptied from the tank in order to make it more livable for the fish. And a lot of water can evaporate during the tank over the weeks that it's just sitting there. So keeping the water level at a certain point is important, and it's a major concern for fish owners. So we controlled our water level using 3 float switches, as seen here in the back. There is a low, a medium, and a high level. These liquid level sensors are essentially switches. There's a magnet inside each of these caps, and as the water rises and the caps float, a magnet will float up with it inside the cap and it'll open up the switch. These are normally closed switches, so when the magnet rises, it opens up the circuit, and that's how we're monitoring the levels on the microcontroller. So we use 3 LEDs to show the user where the states are. There's a low, a medium, and a high. And when the water level gets too low, as it is right now, it's only in this first cap, the water level is low, and the pump is designed to kick on. Our AC portion control of our circuit did not quite work. We had difficulties with the optocouplers. But originally we were going to control it using the microcontroller to manage the AC power. In either case, we'll now demonstrate how if we raise the water level, the normal water level will kick on and the green light will come on. So water's being filled up, and now the water level has reached the second one, and the normal light has now been activated. So if we turn off the pump, like I said, you can now see how the water level has risen up to the middle, and this green light has come on now. But if we turn on the water again, and keep raising the water level, should there be an error in the pump design, and the water keeps filling up, and say it gets up to this third point here, this float switch turns on, and now you're in the high state. This third light is on, and the green light down here, which was the pump control, is now off. We're now in the high state, and water is too high in the tank. So you still have to manually drain the water at this point, but it just simulates when the water gets down to that point. So if we drain the water again now, if we drain the water down past the high, the water is now down to low, and the pump would kick back on. So that is the first portion of our project. The second portion is temperature control. So the temperature is controlled via a LM335 temperature sensor. That is, you can see right here on the inside here. This creates a direct millivolt per degree measurement. And there are 3 separate temperature ranges we're using: a low, a medium, and a high once again. And we set these ranges using these 3 switches here, depending on which range we want to be in. So in the low range here, which is this blue light here, the range is about 65 to 68 degrees Fahrenheit. If we use this one here, we're now in the medium temperature range. That's about 72 to 75 degrees. That's a typical fish temperature right there. Like a goldfish or whatever freshwater fish you're dealing with. And now if you use the third one, you're now in the high state, and your water temperature is about 75 to 80 degrees. That's the range that we set it to, and that's a tropical freshwater fish or saltwater fish temperature right there. So using the input from the temperature sensor and then defining what range of water you're in. So should we say we want the water to be between 65 and 68 degrees, this water temperature is within that range, because this light here on the bottom, which is now off, would tell us when the heater would need to come on. If we're in the medium, it's still off because the temperature is still above 72 and 75 degrees. Here, though, however, the water is less than 75, is less than the 75 or 80 degrees. So this would signify that the heater is turning on and that the water temperature is now rising to reach the 75 and 80 degrees. The next portion of our project is impact warning, and that can be seen by this FSR on the side of the tank. The FSR, or force sensitive resistor, is directly that. It's just a resistor, and it decreases in resistance as the force on it increases. So you push on it, and this light comes on. So the whole purpose of this is to just let you know, is you have kids or in a home setting, people like to tap on the side of a tank, see the fish, and that's really not ideal environment for a fish or any animal. So using the FSR, we can warn the user when the tank has received an impact. Now, we use a reset button, so it forces the user to recognize when the tank has been impacted. So if we tap on the tank, the light is now on, and it remains on until this reset button is pushed. And after the reset button is pushed, the light turns off. And you turn it off. So that's how the impact works. The final portion of our project is angle warning, and we're using a SCA 121T inclometer to determine when the tank is tilting. And that is useful for a small home application, kids bumping into the furniture or shaking things around. That kind of application is useful. This was kind of an expensive sensor, and we weren't originally going to use it for this application because obviously a tank should never be tipping on any circumstance anyway, so it doesn't make a whole lot of sense. But originally, when we were designing our project for our senior class, we were going to make a package monitoring system, one that would record data as the package is shipped across the country. If the package is tilting, humidity, temperature, whatnot, and that's what we used for, so it had to be a little durable. So that's what that's for, and overall it has a range of about plus or minus 30 degrees, but we're only using about 10 to 15 degrees on this. So should the tank tip, which is kind of hard to see that way, but should the tank tip, this light down here turns on. If it goes back to normal, turns off, and then you have both X and Y directions, and it's designed to be at a nominal point. So those are all the four aspects of our project. Like I said, once again, we have water level, temperature control, impact, and angle. And like I said, we were unable to get the AC power to work, but I think this was an accurate representation of our electromechanical skills over the years. Hope you've enjoyed, and that is the end of our demonstration.